Okay, so today we're working with the law of cosines, which is actually simpler to work with than the law of sines because there is never, ever, ever, ever an ambiguous case. It is always a straightforward scenario. There is always a solution. There is always just one triangle that actually works. But the law of cosines is for the scenarios where the law of sines doesn't work. And that is going to be scenarios such as, if you remember from geometry, SAS or SSS. In other words, if we have two sides with the angle in between, or all three sides of a triangle, then what that means is, if you look at that, in either of these cases, if I have this side and I have the angle in between them, that gives us our SAS scenario. You'll notice that at no point do we have a pair that are across from one another. So I would need this side, or I would need one of these angles for the law of sines to work. None of the ratios would be complete, so the law of sines would be worthless to us. So, or side, 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 well, I don't have any angles, so therefore I don't have enough information to go with pairs that are across from one another. So, the law of cosines is actually based on, it's kind of a combo of Pythagorean theorem with a little trick. So, the law of cosines is a squared equals b squared plus c squared minus 2bc times the cosine of angle A. So it's a slightly longer formula that, yes, you will need to memorize, but it is actually a much easier one to use, and you'll see that particularly because of the lack of ambiguous case. Now, we can modify, we can rewrite this in terms of B or side C, so we could actually write this as b squared is equal to a squared plus c squared minus 2ac times the cosine of b, or we can write it as c squared equals a squared plus b squared minus 2ab times the cosine of c. It's all the same formula, and so you'll notice the pattern holds that it's the one side is equal to the other two squares added together minus 2 times those two sides that we had over here times the cosine of the angle associated with the side that's across from it. So regardless of what we call A, B, or C, we can apply it to any of those cases. So we're going to look at two examples today, one doing an SAS style and one with an SSS style. They're going to be similar, but there are some small differences. So for the first example, we're going to look at a SSS scenario. So for example 1, we are going to look at, let's say A is equal to 6, B is equal to 8, and side C is equal to 12. And so our job here is to find all three of the angles that are missing. So technically it doesn't matter which one we start with, although it's a good idea to start with the biggest one first. So in other words, if I look at my three sides, I'm going to go ahead and start with the 12. So that means I'm going to be solving for angle C. So what I'd want to do here is set it up as the c squared formula equals a squared plus b squared minus 2ab cosine C is going to be the version of the law of cosines that we're going to work with. So that's going to leave me with 12 squared equals 6 squared plus 8 squared minus 2 times 6 times 8 times the cosine of angle C. And that's the piece that we're actually looking for here. So if we go ahead and simplify this out, we're going to get 144, 36 plus 64 minus 2 times 6 times 8. 2 times 6 times 8 is 12 times 8. That's 96 cosine C. And then if we do some simple put togethers, these two right here is going to just come out to 100. So I'm going to subtract 100 from both sides. That's going to give me 44 is equal to negative 96 cosine C. One of the things you really want to watch out for is a mistake that people make sometimes is they want to go ahead and add these three all together. There's a problem right here. This 96 is not just 96, it's 96 times something. So it's kind of the scenario what we have. We would have 100 minus 96x, let's say. You wouldn't actually subtract the 100 minus 96 because these are not like terms. So that's why we definitely don't want to do our calculation putting all of these numbers together, because this 96 is not just 96. It's attached to that cosine C. So that's going to leave us with 44 is equal to negative 96 cosine C. Of course, I'm going to divide by the negative 96, which is going to give me negative 44 over 96 is equal to cosine C. And then, just like we did before, we are going to, when we did the law of sines, we are going to arc cosine both sides to actually find the actual value of angle C. So when we type that into our calculator, arc cosine of negative 44 over 96, we would come up with our angle C is equal to a value of 117, 2796, so I'm just going to call that 28 degrees, and that's going to give me angle C. And so right there is our first value, our first angle that we need to find. We're going to find all three angles. And so we have options here. What we can do actually is we can do the law of cosines again and repeat the process for the other ones, or actually now that we have an angle, we can apply the law of sines. And usually that's easier because the law of sines is simply a ratio. So 12 over the sine of that 117.28 is going to equal, and then now I can pick either angle. I'm going to go ahead and do angle A. So let's do 6 over the sine of angle A. And then when we cross multiply and solve, we're going to get 12 sine A is equal to 6 sine 117.28. And then when we divide by 12, we're going to get our sine A is equal to this fraction right here. Actually, why don't I just get the decimal version? It's easier than rewriting. 6 sine 117. Actually, even better. 6 sine answer. I can use the answer button on my calculator. Divided by 12. And that's going to come out to approximately 0.44439, so I'm just going to call it another 4. And then we are going to, well, this is the sine of A. I don't want the sine of A, I want A, so I'm going to arc sine. So when we arc sine that value, we're going to get our angle A is going to be equal to approximately 26.384 degrees. And then finally the last thing, so that's the second answer that we're looking for. And then the third angle that we're looking for, we can find, well, we could use the law of sines or the law of cosines again if we wanted to, but even better than that, we could simply take the two angles that we've already found, and how do you find the third angle of a triangle? Well, you subtract from 180. So we could just do 180 minus 117.28 plus 26.384 to get our angle B value. So 180 minus 17.28, and then I'm going to subtract another 26.384, and that's going to give me angle B as 36.336 degrees, and now we have discovered the third angle. For the second example, we're going to be looking at the side angle side scenario. So we're going to have an angle given at, let's call it 80 degrees, angle A. Side B is going to equal 16, and side C is going to equal 12. So if we take a look at what this would look like, again, we don't have any across pairs from one another, so we couldn't use the law of sines, so we've got to use the law of cosines. So as we set up our law of cosines, we need to use the A version of the law of cosines because that's the angle that we have to work with right here. So the version of the law of cosines we're going to work with is A squared is equal to B squared plus C squared minus 2BC times the cosine of A. And we have to use this version of it because it's the only one that's going to make use of the information that we had given to start with, and that was angle A being 80 degrees. So what that means is what we're going to be finding first is going to be side A. So this one actually works out to be pretty straightforward. A squared equals, and then we can just plug things in, 16 squared plus 12 squared minus 2 times 16 times 12 times the cosine of 80 degrees. Now, the beauty of the SAS scenario is that everything that you see on this side right here is just a number. There's no actual algebra that needs to go into it. So this is just one big giant calculation. So in fact, you don't even need to do this in parts. You can just type this whole thing right into your graphing calculator and it'll perform that whole calculation for you, and it's going to leave you with A squared is equal to, and it comes out to approximately 333.319. And then we've got A squared, we want A, so we can just square root both sides. And that's going to give us an A value of the square root of this number is approximately 18.257. So we've already found the first piece that we need. Okay, so there's phase one of the three things we need right there. So now that we have side A, that means that we actually have an opposite angle and sides. So again, we can just switch over to the law of sines because it's such a shorter thing. So 18.257 over sine 80 is equal to, and then doesn't matter which one we do first next, I'm just going to go ahead and do B. So let's do 16 over the sine of B, and That's going to cross multiply and solve, so 18.257 sine B is equal to 16 sine 80, and then we're going to divide by the 18.257, and that's going to give us, shrink that down a little bit, and that's going to give us the sine of angle B is equal to this value, which if we just go ahead and type that into our calculator, it's about 0.86306, so we're just going to call that 1, and then we're going to want to find angle B, so that means, again, we're going to arc sine that decimal. And what that should give us is an angle B value of approximately 59.662 degrees. So there is the second part of our answer. And then we just need one more item, and that is going to be angle C. So we've taken care of this one. That leaves us with angle C as the last one we need to find. And the last angle is always the easiest, because we can just do 180 degrees minus the two angles that we already know. So angle C is going to equal 180 degrees minus the two angles we already know, which is 80 plus 59.662, and then 59.662, so angle C comes out to 40.338 degrees. And now we have all three of the values that we needed to find. So now that we've seen all of the scenarios for the law of sines and the law of cosines, some of the problems that you're going to be working on today are going to be straightforward in that they're going to tell you, hey, use the law of cosines in order to solve this. But some of the other problems that you're going to be looking at are going to be where you're going to need to determine whether to use the law of sines or the law of cosines, and then go ahead and solve that triangle. So just as a little recap, we have the law of sines is good for certain scenarios, and that is for two angles and a side, whether the side is in between or not, AAS or ASA, and it is also good for two sides and the angle not in between. Remember, though, that this one right here is our ambiguous case and can lead to one solution, two solutions, where you actually have to find all of the values for both triangles, or the best case scenario, no solution, where there isn't a triangle that's even possible. So you need to judge. It helps to draw it out, but you'll need to judge whether what scenario you have. And then the law of cosines is good for two scenarios, and that is two sides with the angle in between. That's different from the ambiguous case because we're talking about the angle in the middle as opposed to the angle being outside. Or for the three sides scenario, as we just saw. So when you have to figure out which one to use, it helps to draw out the triangle so that you can clearly visually see, am I dealing with SSS or SAS or SSA? And we can tell from the geometry of the situation which one is the appropriate one to use.